Every video so far has been about the model itself. Today's different. Today it's about what happens when you let an AI agent plug into real tools, databases, file systems, APIs. That's the MCP, the Model Context Protocol. And it just become one of the newest attack surface in AI security. Quick architecture first, because you need this to understand every attack we are about to cover. The MCP client, that's the host application. Think cloud code or cursor. It discovers available tools, hands them to the LLM, executes whatever the model asks for, and returns the result. MCP server. This exposes access to one specific system, a database, a file system, an API. Two transport methods here. STDIO for local servers, simple input output, no network exposure, and streamable HTTP for remote servers, which absolutely needs TLS encryption and need authentication. And three primitives you will hear constantly. Tools. These are the functions the LLM can actually invoke. Resources. Data attached to context, like file content. Sampling. The server asking the model for a completion, which flips the direction most people expect. Let's talk about tool poisoning and rug pull attacks. Now the attacks, tool poisoning, a malicious a malicious MCP server writes a tool description designed to manipulate how the model uses it. The model trusts that description to decide when and how to call the tool. So a poison description is really an injection vector straight into the model's decision making. Second, rug pull. A server shows you a completely benign tool description, reads public weather data. You approve it. And after that approval, the server silently swaps in different malicious behavior. Same tool, same name, completely different actions. And once an attacker has two tools working together, say a database query tool and an HTTP request tool, they can chain them. One reads sensitive data, the other shape it out. To the model, it just looked like a normal multi-tool workflow. So how do you actually secure the connection itself? The MCP spec recommend auth 2.1 for remote servers, token rotation, scoped permissions, secure storage. What you want to avoid is basic auth, hard-coded credentials, API keys sitting inside a tool description in plain text. That's also capability negotiation. Client and server agree at a startup on which feature are actually supported. Security win here is simple. If a server doesn't need sampling, it shouldn't be able to advertise it in the first place. And logging, every tool invocation should capture the parameters, the timestamp, the outcome, and who requested it. Without that, you have no real incident response story at all. Last piece, hardening the server itself. And this is where most of the real protection lives. Container isolation is the strongest control you have. Each MCP server runs in its own isolated container. Minimal network access, restricted permissions, so one compromised server can't reach another server's data or the host system underneath it. For server touching the file system or database, path sandboxing to stop direct traversal, and parameterized queries with read-only least privilege credentials, never arbitrary SQL, never admin label access. Keep the tool surface minimal. Retrieve order status by ID in a completely different risk profile, then execute any SQL query. Design narrow purpose build tools, not general purpose ones. And for anything sensitive, sending an email, modifying data, making a payment require explicit human confirmation before it executes. No exceptions just because it's just an AI agent doing it. Let's recap what we have learned so far in this lesson. 1. The MCP client is the trust boundary between the model and every server it can reach. 2. Tool poisoning and rug pulls exploit the model's trust in a tool's description, not just its code. 3. Auth 2.1 tight capability negotiation and full invocation logging are the baseline for the connection itself. 4th, container isolation, path sandboxing, and least privilege credentials are non-negotiable. 5th, minimal tool surface and human confirmation for anything sensitive or irreversible. In next video, we will go one level up. AI agents orchestration, and the very real risk of wipe coding your way through a code base. If this was useful, hit subscribe and I will see you in the next one. Thank you for watching this.